Hi, everybody. I'll talk about taking containerized applications to production and what can be done to simplify the process. I assume you know at least a little bit about containers and Docker files. So, what's the problem? Creating a basic containerized application is pretty simple, but making it production ready is actually a lot of work. Here's a couple of examples of what other people said about it. Docker files are easy, they said. Then I had to handle proper caching, proper security, proper reproducibility, proper config management, proper portability, and proper reusability. Turned out not to be so easy. I spent 2 weeks building the POC and then 8 months passing compliance. 8 months is a long time to get to production. Some of it is technical and some of it isn't, of course. There's a lot to care about when it comes to production. I'll focus on image composition, but I want to mention a few other things as well. When it comes to the ops plane with logging metrics and monitoring, it's more about integrating with what you have. There are many different reasons for complexity there. Some of them are container related, while others are legacy related. If you can do one thing for the ops plane, make sure you have structured logging, with JSON, for example. And if you can do two things, make sure you log to the console. It'll be a lot easier to integrate with many container logging infrastructure tools out there. Dealing with secrets in a safe way can be a headache. The biggest no-no, of course, is embedding secrets in your container images. Using environmental variables for secrets is not a good idea either. Security and compliance in general end up taking a lot of time because it requires a lot of manual work and because it requires security-related domain knowledge. The build and deploy times are super important when you develop your application and when you release it to production. It almost always feels too slow, and you don't want to make it a lot slower with containers. Now that we have a bit of context, let's look for a containerized Hello World app to start the journey. I picked the first match I found on the internet. It's simple enough, and it turned out to be a good example for this talk. It's a web app listening on port 3000. The Docker file is pretty small and simple, and it has a few common problems, so it's perfect. It uses a standard node base image, it installs the app, and it configures the container image to run the app on startup. When we build it, we end up with a container image that's almost 1 gig in size. So, what's wrong with the image and its Docker file? Let's take a look at the Docker file again. The first thing that jumps at you is the image size, of course. It's a simple Hello World app, but it's almost 1 gig. The second problem is related to caching. If we update the application code, we'll end up reinstalling the dependencies, even if we don't change them. That means slower container image build time. Because we don't have the user instruction in the Docker file, it means we're running as root. And running as root is definitely not a good idea for production. Reproducibility is another problem we'll need to address. We're not using the latest node image as the base, which is actually great, but we're only pinning the major node version, and we can do better because we can still end up with breaking changes. Another reproducibility problem is application specific. npm install may end up installing something different from production. We also have a hidden problem. The entry point for the node container image is actually a shell script. And that shell script doesn't handle the system signals properly. It means that your application won't get the signals. It means no graceful shutdown and other signal-related side effects. Good news, we can quickly fix it with the init runtime parameter. Many of these problems are pretty common, and they're common gotchas. Most Docker file examples out there are not good for production. They're not meant to be, though. They usually show only the most basic concepts. One of the major gotchas, especially for people new to containers, is related to deleting files. If you don't delete the files in the same run instruction where they get created, the files will not be deleted. It will just look like they are. One of the commonly overlooked gotcha is related to large build contexts and the slower build times they cause. When you build an image, you specify a context directory for the build. Everything in that directory gets bundled into a tar file, and then that file is sent to the Docker daemon. It means the locally installed app packages, for example, and other junk will end up in that tar file, unless you exclude them in the .docker ignore file, which is similar to .git ignore. There are a few small enhancements we can make to the Docker file to get us closer to production-ready containers. So let's start there. Using a more specific version for the base image on line 1 is the first quick win. Doing the same for the OS and application packages is a good idea too. There's a number of language and framework-specific ways to ensure we end up with the dependencies we expect. For Node.js, it's using npm CI instead of npm install. You can see it on line 4. One of the other enhancements is related to removing the unused package cache files. It's also specific to the language and the package manager you use. You can see it on line 4 as well. The instruction on line 4 installs the application packages and it deletes the package cache in the same Docker file run instruction to make sure we really delete the files and we don't create an extra layer. The last application-related enhancement is about installing the application dependencies separately from the application code. That's lines 3 and 5. Now, changing the application code doesn't invalidate the image layer that includes the installed dependencies, and this improves the container image build time. Using a non-root user in the container is another quick win. That's line 6. Many language-specific base images already have a non-root user. For the Node.js base images, it's Node. After making these enhancements, we end up with a slightly smaller image. Don't worry, you'll get better results with the real application. The enhancements we made to the Docker file represent some of the most common best practices for container. There's a lot more, of course, and I won't be able to cover all of them here. One of the important themes in the container best practices is keeping your images as small as possible. Some of the recommendations are pretty funny, though. For example, don't install the tools you don't need. Well, if you install something explicitly, it implies that you actually need it. It's not always clear what you need and don't need, though. And what you do need might be a subset of what you install. Figuring out manually that is super painful and pretty time-consuming. Using smaller base images is considered to be one of the best ways to reduce the application image size. There are a number of options out there. Using Alpine is a pretty popular recommendation because it gives you a much smaller image. For example, Alpine with Node is about 115 megabytes, while the default Node.js image is 940 megabytes. Using Alpine sounds good on paper, but it's not always straightforward. It's good if it works for you, but there are many reasons why you might end up with other base images. Developer experience is one of them. The package manager ecosystem is another one. It's also a lot easier to find examples for Ubuntu and Debian. There are other options, including distroless. Node.js with distroless is about 120 megabytes, but I'll talk about that a bit later. If you're considering Alpine, do a bit of research and a spy to see if it's a good fit for you. There are a lot of gotchas to explore. Many people who start using Alpine eventually move away from it, learning about the Alpine gotchas the hard way. Speaking of the hard way, let's make more manual improvements to our container image. I'll skip manual image hardening. It's complicated, it's messy, it's brittle, and it's time-consuming. And we already got a taste of what it's like to manually optimize the Docker file instructions with our application dependencies. There are a lot more there. I'll focus on the multi-stage and smaller base image steps. Multi-stage builds is a relatively new Docker feature. You build your app in one stage, and then you copy the application artifacts to the next stage, where you assemble your deployment image. You can think of the multi-stage builds in Docker as a native implementation of the builder pattern concept. The main gotcha with multi-stage, aside from added complexity, is that you need to know what has to be copied. This means that unless you have a single file or a few files, you're copying everything possible. I've seen that many times. Let's see what our Docker file looks like with multi-stage. Here we copy the application folder to our deployment image. That's line 13. We don't need to clean the package cache in the first stage on line 5 because it's not going to be included in the deployment image. Other than that, it's mostly the same instructions, but two from instructions that represent two stages. Let's see what we get. We end up with a slightly smaller image. A real web application with React or Vue or another major framework will have a much bigger difference there. Now let's see what we need to do to have an Alpine version. And here we only need to change the base image stack. Everything else is the same. But this version, the image size is much smaller, 118 megabytes. Pretty nice. Another option is distroless. Distroless is a stripped-down version of Debian with no shell and no package manager. The distroless image for Node is 121 megabytes, which is pretty close to what you get with Alpine. Aside from no shell and no package manager, there's a couple of other gotchas to keep in mind. First, you have to use multi-stage builds. Second, not all languages are officially supported. For example, there's no official Ruby support. The Docker file needs to be tweaked a little bit as well. There's no node user, and the command instruction format is slightly different because the default entry point is also different. With the distroless version, the app image size is close to what we get with Alpine, 122 megs. That's pretty great. That was fun, but as a developer, you probably want to spend more time working on your application and less time with Docker files. There are a number of options that will get you closer to production-ready containers and with a lot less manual work. These are great options to consider if they work for your app. These tools simplify container authoring, and they give you at least some of the basic image optimizations. Build packs are the most mature and consistent option because of their pass routes. You don't need to write any Docker files. Just point the build packs at your application code. Let's see them in action. To use build packs, you can get the pack tool, or you can use Waypoint from HashiCorp. Either way, you choose a builder type that's responsible for building your application image, and you can choose which build packs the builder should try, or you can rely on the application detection logic in build packs. Depending on the build pack vendor and the builder type you choose, you'll end up with slightly different images. They'll have different sizes, they'll use different non-root users. With build packs, you also need to define a proc file to declare your application entry point, or you will need to structure your application in a certain way. For example, for Node.js, you need to define the start script in the package.json file. Keep in mind that these tools are pretty opinionated and with limited ability to customize for some of these options. With build packs, you can customize quite a few things though. You give up control so you can do a lot less. It's definitely worth it if it works for your app. Build packs and the other tools give you a number of basic image optimizations, but there's a lot more that can be done at the OS and application level. For example, your application might need the AWS SDK package, but it might not need all of it. This is where Docker Slim shines. Docker Slim can do a lot of different things. Optimizing container images is one of its best-known capabilities. It uses an application-centric approach to figure out what should be in the container image and what shouldn't. You also get to spend a lot less time on vulnerability management and image hardening, in addition to getting security profiles you can use at runtime. On this screen, I executed the build command for Docker Slim. It took our original 945 megabyte container image and it generated an optimized image that's about 80 megs. Docker Slim uses a combination of static and dynamic analysis to generate optimized container images. Ping me if you want to know more about the internals. You can also use the X-ray command in Docker Sling to see what the optimized image looks like, how it's structured, and what's included. In this journey, we went through a number of revisions for our containerized application. We started with an image that had a number of problems, and it was almost 1 gig in size. And we ended up with an optimized image that's 80 megabytes. Depending on the path you choose, you can have optimized production-ready containers without ever touching any Docker files. Creating a production-ready containerized application doesn't need to be complicated, and you don't need to do it the hard way. A few takeaways. First of all, keep it simple. There are many great tools out there that will help. And if you need to have custom Docker files, make sure you don't run as root and you install your application dependencies separately from your application code. If you have any questions, feel free to reach out anytime. Thank you.